Okay, so our next speaker is Hege Tapio. She is artist curator and founder, as well as founder and manager of IOLab, Center for Future Art, Framtidskunst, in Stavanger, in Norway. And Hege is also organizing article biennales in Stavanger, which are more focused on art and science, and particularly on bioart. And she herself is studied fine arts and photography, and her interest also has been made this transition from more like a photography and apparatus to art and science interests, and also of using and understanding the technologies, and also experimenting with science and particularly with bioart. Okay.
Thank you. Just going to place this. So I just wanted to present a little bit about the road into art and science and bioart, and also I'm going to talk a little bit about the projects that IOLab's been involved with over the years. So we're based in Stavanger. It's about just a 20-minute flight south from Bergen, and it's a very small organization, but we have done a lot of projects. It started in 2000, and it was supposed to be like we were thinking initially like a media lab for artists working with electronic media, but things changed really fast at that time. In the early 2000s, suddenly artists were getting access to computers and software and knowledge like on their own. And also at the same time I met Oren Katz from Symbiotica in winter 2001. To me it was like a revelation to see how artists really is getting deeply engaged into a hardcore technology and working in a lab. So that I found very interesting. So that's somehow also how IOLab kind of developed towards art and science, and started to collaborate with artists and to initiate projects that would integrate science into the work. Yeah, so it's mainly bioart, which is a special interest field of IOLab. And I think it's, one of the earliest collaborations we did, we were in contact with Steve Kurtz from Critical Arts Ensemble. We were supposed to have a workshop in 2004 where we were going to address biowarfare, and to have a small workshop working with bacteria, just simple bacteria that you could find in your house, basically. Unfortunately, as we were planning this workshop, I got an email from Steve saying, probably you know the story, that his wife died, and as the ambulance people were entering his house, they saw all the material, lab equipment, and books about biowarfare, so they just called in the full hazmat suit people and confiscated everything, even his cat, his passport, and his deceased wife. So it was pretty dramatic. Nevertheless, we did make a workshop in Stavanger a year after, in 2005. We had to call off the idea of working with bacteria-related workshops, so we did more of a social intervention, which was quite fun. But I think it's also really interesting to see the shift that's been made with GenSpace. There's a lot of spaces going on worldwide, also with the DIY bio labs popping up, which is forming some sort of a citizen lab, and also a space where artists can come in and work with the technology, because it's really it's quite hard for artists to get into a real research lab and to get in dialogue with scientists, because there's a cultural difference, and scientists are very they have these preconceived notions about artists and really hesitating to letting them into the lab. And also the artist needs to acquire the language and the way of working and thinking to enter the lab. I was lucky to attend to the Bioart masterclass that was done by Symbiotica and the Arts Catalyst in London in 2005 also. And later, over the years, we have collaborated with Symbiotica on several projects. So this is some pictures from the article biennial that was done this year. I'm going to talk about some of the works that was exhibited in that exhibition. This is, if we roll back to the article biennial in 2008, we did a masterclass in bioart together with Symbiotica and the university in Stavanger. So we had a lot of international artists that applied to attend to the workshop. A lot of those artists has, in the aftermath, been developing and working with quite some interesting projects. And I think that the masterclass really created to them the basic tools and language and understanding to enter and to start to collaborate with science or scientists. And this is from the workshop. They went through a lot of basic tutorial classes, like making bacteria glow with the use of the GFP gene. Excuse me, I'm catching on to a cold, so. And also the workshop was having a lot of instructions of how to build up a lab at home. The picture to the right is the artists working on building their own sterile bench or laminar hood, making use of some kind of a plastic construction and also connecting it with a fan, airflow with a HEPA filter that would clean the air. And also the picture on the left is how to extract DNA, making use of household products. So I really like that kitchen bench attitude and approach towards science, and it also has a lot of roots in do-it-yourself culture that you can spur quite far back in history in American society. Also, in 2008, we invited Jun Takita to develop his project, Light Only Light. This is a sculpture of his brain. That is, he scanned his brain and then made a biopolymer sculpture out of his own brain. And the idea was to cover the brain with moss that was fused with the GFP gene. So he wanted to make his brain glowing. And we tracked down a venue to exhibit his piece. We found a lighthouse right outside of Stavanger city. And we wanted to place his glowing brain, instead of the lamp there, we wanted to have this glowing brain into the lighthouse. So we had to go through a process of contacting to get approval of exhibiting this work, and that was a tricky affair, but we did it. And we also had to find science to collaborate with Jun Takita. We managed to track down some scientists in the university in Sweden in Stockholm, which collaborated with him to make the transgenic moss and to apply it onto his sculpture. And then Yun was he did not want to bring the sculpture with to take the flight, so we had to do the train trip to Stavanger to bring it over. So this is the sculpture. It was exhibited in this container, also to prevent contamination. Although you can see all to the left of his sculpture, there's already been growing some fungi, so it's pretty difficult to keep everything sterile. But we did, nevertheless, we did a test, and we sprayed the brain with luciferin, I think it's called, yeah, which is going to activate the gene and to make it start glowing. So we completely darkened the room where it was placed, and as the eyes really adapted to the dark, you could really see that the brain was starting to glow. It was a very weak glowing light, but it was very fascinating to see this living light and how it behaved. He's also tried to make some pictures out of this with some special photographs. Later on, we've also had some events that was addressing the notion of lab-produced meat. We did a cookout. We did invite scientists and chefs and artists to do a project called Art Meat Flesh. This is a project that was initiated and done by Symbiotica. It was first shown in the Netherlands, and so we invited them to do the same event in Norway during our article biennial in 2012. And I don't know if you've seen the famous TV show where they have these secret ingredients, and then they're supposed to make several dishes making use of the secret ingredients. Well, the secret ingredients for this event was the fetal bovine serum. Yeah. And to the left we have a jelly man made of the fetal bovine serum, and we invited the audience to come and taste all the dishes that they prepared. Some of the dishes were good. Some of the dishes were had a quite pungent taste of this fetal bovine serum, which doesn't really taste very good, I must say. So fetal bovine serum is actually the nutrient that is being used to grow the cells to make in vitro meat. And in vitro meat is kind of being focused on as dissolution of having a victimless beef or a hamburger, but in fact it's not victimless, because the origin of the fetal bovine serum is calf fetus, so making use of the water and the nutrient and the blood from the calf fetus. And I was once told how many cows that needs to die for 500 milliliters of fetal bovine serum, and it's quite significant. I don't know cannot remember the amount. 20. Thank you. Well, so I think the discussion around if a lab-grown meat is sustainable or not, I think just the fact that you kind of have hidden victims into the nutrient solution is one aspect, but also to grow the meat in a sterile condition, you create a lot of waste products, because you have to make use of plastic material that you throw away. Also, for the article biennial that was presented this year in February, we invited Paul Vanus. The theme of the article biennial that was run in February this year was art, DNA, and nano. So we wanted to invite artists that was working directly with DNA and nanotechnology to kind of focus on how as artists engaging and making use of the small or the smallest building blocks, so to speak. And Paul Vanus is one of the artists that I know has been working for a long time with the DNA technology. Paul Vanus he's an artist, but his science background is somewhat of a do-it-yourself kind of. He doesn't have like a scientific degree, but it's more like what he's acquired over the years for his special interest into the field, which is he's somewhat become quite, acquired some special knowledge around how to deal with the DNA. And we showed one of his oldest pieces, or one of his older pieces called Latent Figure Protocol. Do you know this piece, by the way? Okay, so I'll try and talk a little bit about it. When Paul got familiar with how they used the analyze for the DNA, as you know, you put the DNA into this gel. You have some wells at the end, like at the base here. There's some chambers, so you put the enzymes into those chambers, and then according to the size of the molecules, they will travel up in a line, and then will leave a trace, and thereby you can distinguish the what type of DNA you are dealing with. And since Paul Vanus is an artist, he was trying to think the other way. Well, how can I create images making use of this technology? So what he did, he set up, he made software that could help him analyze what kind of enzymes he would need to get the exact marker on for the picture. And then he tried to work with symbols, very simple symbols. Like the picture on the left is the eternity symbol, and the picture on the right is the copyleft symbol. Actually, for the copyleft picture, he also used a copyrighted enzyme, so thereby also commenting on the piece by using the copyright symbol. So he wrote this software. The software would analyze what kind of enzymes he would need to get the exact marker, and he then got a list of all the enzymes needed to make each picture, and he sent it in and got the DNA synthetically produced, and thereby he could use this DNA, and when he ran the the gel, he would get the symbols that he planned. So this is the copyright symbol, and the patented enzyme is called PET11A. Yeah. And he also exhibited. We also exhibited one of his other projects called SIC, or Suspect Inversion Center. The acronyms of SIC is also playing upon. I'm sure you've known a famous TV program called CSI. Are you familiar with this work with Paul Vanus? No, okay. So I'll talk a little bit about it. So SIC is a project that was that Paul started to work with after the case of. Oh no, it's slipped my brain. The name of the famous sportsman in the U.S., which was claimed to be murdered his girlfriend and O.J. Simpson. Thank you. So, which was the first case in the States where DNA was used as a proof in the court. And although he was claimed to be innocent, it caused a lot of discussions of whether you could use DNA as actual proof. You know, can we trust it? And Paul Vanus is he'd already been doing his work with the latent figure protocol. So, with his experience of how you could manipulate the enzymes to create whatever image you want, he thought it would be interesting to have a look at this notion of how we believe the DNA as a proof material. You know, how can you really trust it? If he can manipulate the pictures, then why would it not be susceptible to believe it is like the fingerprint, that you cannot manipulate it at all? So what he did in this work, he set up a lab. This is from the museum, how it's exhibited. So he set up a lab in the museum, a working lab. And the project is, he managed to track down the actual DNA imagery that was used in the court case from O.J. Simpson. He found it in the database of the national database. So he started out by making use of his own DNA, and thereby using the software he already created for the Latin figure protocol. He works how does he have to manipulate his own DNA and mix it with enzymes to make it become O.J. Simpson's DNA, visually, of course. So he's nearly completed. He's managed to manipulate his own DNA with enzymes to make the markers come almost at the exact places as O.J. Simpson's DNA profile. And it was quite interesting to put this into a museum context. It raised a lot of questions from the audience. They were really not really buying into this as art. It was really difficult for them to perceive this as art. Nevertheless, it also required that we got some scientist students to run the procedures and to also be present to talk about the project. And I think without those students present, I think the audience would have so much difficulty to enter and understand his work. So I think there's also a lot of there's such a barrier for not only for artists to enter this science and biotechnology and really understand what it's about, but when we put it into an art context, it's also really challenging for the audience to enter it, because the audience will have, unless the audience has a specific scientific knowledge or background from beforehand, it's really hard for them to enter into it. So how you mediate these types of work is really crucial. That's what we experienced. So this is the students that was assisting Paul Vanus into the work. Here they get the training from Paul Vanus, how to do the procedures, and also how to, get a deep knowledge of his concept of the work. Also, one of the other artists we had present into this biennial was Heather Dewey Hagberg. Are you familiar with this artist?
It's the one who makes the cigarette butts, right?
Yeah, that's right. So Heather Dewey Hagberg, this piece, Stranger Vision, started out as she was visiting her doctor, and she was sitting in a waiting room, and she noticed one of the pictures in the waiting room had a little hair attached into the frame or the glass, and she was sitting there wondering, who's been there before me? Who was this person that left this piece of hair behind? And what can I possibly find out? Can I find out who this person is? And that kind of inspirational thought, really, she carried it with her as she was walking through the cityscape later on during the weeks. She was noticing cigarette butts. She was noticing people had thrown their gum on the street, which all those things carry the DNA trace. So she started this project by collecting all this stuff that she found in the city, and she make photos of the place where she found it, and she also noted some, like a researcher would do, like collecting samples And then she took contact with GenSpace, which is the open lab in New York, and started to work there with her project and started to analyze the found objects, the cigarette butts and the gum, to see if she could find information to reveal who left behind these objects. And of course, there's a lot of information in DNA, so she had to select, okay, what do I need to know to find out what a person looks like? So she had to track down the DNA that would say, or the marker that would say what is the ethnical origin, what is the eye color, hair color. So she she made a list of all those markers that she wanted to identify. And as she was creating profiles to all of these found objects with this information, she made them, the profiles, into this portrait. She created it in 3D, and she got it printed out, 3-dimensional. So the information that she picked up from all the cigarette butts and the gum she found on the street is that's resulting in these portraits that hangs on the wall, and so she's able to somewhat claim that by doing this procedure she can now reveal what they look like, the people that, like, she kind of found their identity, sort of, at least how the, well, it doesn't claim, but she
She really stresses the fact that you can't say what they look like, and that these portraits are very generic, you wouldn't recognize themselves.
But what's also interesting is that through DNA profile, you cannot determine the age of someone. So potentially, the gum she found on the street could be left behind by a 3-year-old boy, and what she's created here is kind of an imaginary portrait of what that 3-year-old would look like when he's 30, because all the portraits that she's presenting somewhat look like they're in their 25, 30 years range. And but I think the project is not so far off from how the police would work with the phantom drawing when they're looking for a suspect. They would take down some information about height, eye color, or how a person would look like, and then would make a fictional portrait of the suspect they were looking for. And I think what Heather's work is resembling that kind of thinking. It's not like she's creating a actual portrait of the person, but more like a phantom portrait. But she is not using collected information from eyewitnesses. She is using the information she has collected from the DNA. And I've heard some rumors that there are police stations that would be interested to look into her way of finding the criminal by using that method. But then again, we had into the article biannual, we had a panel where we also invited Jenna, which is an institute that works with DNA analysis, and they said, well, criminals today are quite aware that you can collect the DNA material, so they will, if they are clever, they will have collected cigarette butts from a previous party they've been to, and they will spread it on on the place where they are doing their deed. So yeah, this is the work of Heather was also displayed with what she'd found. So in the Petri dish, there's a small object that she collected from the street, and there's also the photo of the place and some information where it was found. So, and now also we are working now, me and Nora Våge, which I've invited as a co-curator for the upcoming article biannual, which is going to take place from August till October in 2016. We are working under the title The New Eden, So while the previous article manual was presenting art making use of DNA and nanotechnology, we wanted to kind of look into, now that we have access to all this technology, now that we somewhat know how to tamper with or create or work with living matter, what direction are we heading for? I mean, what is a potential new Eden? Will it be a paradise? So that's some of the questions we want to open up. So we are now in dialogue with artists, and hopefully we can manage to spur some interesting dialogues with the selected works we have. We're going to have hopefully also another workshop with Bioart. We're planning to have a mobile laboratory that's also going to be present in the city and visit schools, and probably also show the program from Biofiction's Film Festival that's touring internationally. So keep an eye on what's going on at our website in the future. We're going to probably do the selection and launch more information around March next year. So hopefully you'll also be inspired to come and visit. If you have any questions, I'll be happy to receive.
I was thinking about the last work you have been presenting with the artist that got all this DNA. This one, I don't remember the name.
Heather, Dewey Hagborg, yeah.
I read somewhere that the DNA, the importance or where the problem could be is the interpretation of the DNA. It's not, I mean, like you can have your DNA and you're like very well done, I mean, very well.
We still don't know what's the real meaning of the main sequence of the DNA. So that's 90%
interpretation.
Yeah, 90% of the DNA we still don't know what is this. Maybe we think that actually it's control sequences. So that's when you see this as like a kind of something. For us as scientists, I know it's an interpretation for an artist, but as a scientist, it's like no, it's impossible still for us. Even with supercomputers, we still don't manage to get the phases for a DNA sample.
Mm-hmm.
Because sometimes, actually, there are accidents. There is the epigenetics. There is another genetics over genetics that actually can change the color of the skin and the color of the eye. So, and that's the thing that you don't see on the DNA. That you gotta go in another level and the cells, but that's quite complicated.
Yeah, I think.
Very sort of nuanced. We should talk about this as well. I mean, part of the reason for this work is that you want to point out both what you can tell and what you can't tell, right? So it's sort of this scary vision of a forensic future where you can actually really pick out everybody's.
Do you know now the forensics, what are they using now? I read the article, they are using, okay, you can collect all the bacteria, and
Yeah,
you can
so
use the bacteria and it's like a fingerprint for a person.
Yeah. But the generic portraits that she creates, it's like what you can tell with some degree of accuracy is stuff like whether somebody has freckles and eye color to a certain extent here, but it's really more of a likelihood than that you can tell. And you can't really tell stuff like how broad your face is or anything like that. It's really very generic.
That's true, and a lot of the people, when I was when this exhibition was up, and I was addressing audience that did have a scientific background, they were like, nah. well, the other part of the audience that didn't have a scientific background, they were like, really? But what was the interesting discussions we had was. Which direction are we heading in the future? I mean, if it's possible to collect information about what kind of diseases you're susceptible with. Well, I mean, what's going to happen with your insurance policy? I mean, there's a lot of interesting questions popping up that could be relevant in the future, and that is worthwhile looking into and discussing, whether this is a real portrait or not. It raises some interesting questions that is worth discussing.
No, that's called genocentrism. But now 2 years ago, we realized that you cannot tell nothing with the genes. There are the epigenetics, the genomics, the metabolomics, the connectomics, the proteomics. There are all the things that are really difficult.
No, this is a scientist speaking, right? He knows. But I also read, like, a couple of weeks ago, they just found the human chimera. So, which he...
No, there are a lot of human chimeras.
Yeah.
Actually. Yeah.
So it's kind of...
when you see somebody in the beach and they have spots in the back, white and black or brown or something, that's a chimera.
Huh?
Jesus Christ, I'm a chimera.
Yeah, actually,
Really
the human chimeras are a fusion of 2 fetuses from 2 genes, from 2 different lines, and they became only 1 human. And this is really common in cats. There are...
So we're kind of complicated creatures, Okay.
Life is complex.
Yeah. Okay. I'm going to leave a catalog here to whoever.
Yes. Before talk. Okay, we're waiting just a couple of minutes for our next speaker to come back. Two-minute break.